Hi and welcome. I am Lakshmi Gulakul, Senior Assistant Professor, MIT Mudbidre. Today in this lecture session 1.5, we are learning Poisson distributions and problems based on it. So Poisson distribution, when the probability of success P becomes very small and the number of trials N are very large, but at the same time N into P, that is mean, remains constant, then Poisson distribution can be effectively used. Binomial distribution finds it difficult to handle very large N and a very small P. Therefore, your Poisson distribution is a special case of binomial distribution. Poisson distribution is the limiting case of binomial distribution. What I can say, when n is very large and the probability is tending to nearly zero and your mean value is finite, then we use the Poisson's distribution. Poisson distribution is given by limit as n tends to infinity, p tending to 0, np is equal to finite times the binomial distribution. The probability of a random variable having Poisson distribution is given by p of x is equal to k, which is equal to np whole power k into e power minus np whole divided by k factorial, where n is the number of trials, p is the probability of success, k is the number of success events. Consider an example problem here. Over a noisy channel, 10,000 digits are transmitted, having a probability of error per digit of 5 into 10 power minus 5. What is the probability of getting only 2 digits in error? Also find mean and variance. Here in this problem, you can see that the number of noisy channel digits are 10,000. Hence, we can go with Poisson distribution instead of binomial distribution. Because the binomial distribution, it is very difficult to evaluate, and hence we go with Poisson distribution, where n represents the number of digits that are transmitted over noisy channel, that is 10,000. P represents the probability of error per digit, which is given in the question as 5 into 10 power minus 5, which is written here, and k is the digits in error, that they are asking you to find the probability of getting only 2 digits in error, hence k is 2. We use a Poisson probability equation, distribution equation, p of x is equal to k, which is equal to n into p whole power k into e power minus np whole divided by k factorial. Find out what is n into p. N is 10,000 into p, which is 5 into 10 power minus 5. You will get answer 0.5. Putting the value in the above equation here, you will get 0.5 power 2 into e power minus 0.5 whole divided by 2 factorial. Calculate in the calci and you will get the answer as 0.076. So here for Poisson distribution, they have asked you to find the mean and variance. Mean is equal to variance. For Poisson distribution, mean is always equal to variance, which is equal to n into p, which is 0.5. Remember, the mean and variance for Poisson distribution is np, which is equal to 0.5. Now we'll look at Poisson approximation to the binomial distribution. Very important topic. May ask in the exam to find the Poisson approximation to the binomial distribution. May ask you to derive the expression. Here I will explain you. Consider the binomial distribution. The equation was explained in the lecture 1.4. So now the same equation is copied here, which is equal to nk p power k into 1 minus p whole power n minus k is equal to, what is this nk in the bracket, round brackets represent n factorial divided by n minus k factorial into k factorial into p power k bracket 1 minus p whole power n minus k. In this equation, let us consider lambda is equal to np. So then your p will be lambda divided by n. Then p is equal to lambda by n. Then above equation can be rewritten as n factorial divided by n minus k into k factorial. P P is now here. P is replaced as lambda by n. Replace P with lambda by n. So lambda by n whole power k. Then P again 1 minus P again is replaced. Here P is replaced as lambda by n whole power n minus k. So we know that n factorial is, or in example 4 factorial is 4 into 3 into 2 into 1. Similarly, if you have in general n factorial, which can be written as n minus 1, n minus 2 into so on, n minus k plus 1 into bracket n minus k factorial. This n factorial can be written as the expansion here, okay, into lambda power k divided by n power k, and the denominator terms as it is here written. So then you need to rewrite this equation. What is this you will get here? 1 minus lambda by n whole power n into, it is 1, you just split up the power here. You will get 1 minus lambda by n whole power n into 1 minus lambda by n whole power minus k. Minus k can be taken into the denominator, then that term will become 1 divided by 1 minus lambda by n whole power k. So the above term is rewritten here, the n power, and this is minus k power. So minus k can be written in the denominator as k, hence written here. Then now cancel out the common terms here, n minus k factorial will get cancelled. Rewrite the terms here. Take this n power k onto the other side, k factorial here onto the denominator. You will have to rewrite the equation. After rewriting the equation, we know that for Poisson distribution, large value of n takes the large value and the moderate value of lambda, because lambda is equal to n into p, which is finite. So n1 minus lambda by n whole power n will be nearly equal to e power minus lambda. We have this equation in your PU, which is e power minus lambda is given by 1 minus lambda by n whole power n. So there in your second PUC or in your secondary school, the mathematics, we wrote it as e power minus a as 1 minus a whole power n. Similarly here e power minus lambda, this term is equivalent to what? E power minus lambda. So the terms that you have here, n minus 1, n minus 2 up to n minus k plus 1 divided by n power k is nearly equal to what? 1. So this is again the multiplication which will give you the sequence, the multiplications of n series sequence, that is n power k. Both the denominator and if you take this ratio, you will get 1. So similarly here 1 minus lambda by n whole power k is nearly equal to 1. As your n is very large, you will get 1. They hence substitute in this equation. So we know that the first term here is 1 into lambda power k divided by k factorial, and this term is e power minus lambda, and the denominator term here is 1. Rewrite here, written here equation. So then you will get the answer as, final answer is lambda power k e power minus lambda divided by k factorial. So what is your lambda here? Which is n into p, the mean of the Poisson distribution. Lambda represents the mean of your Poisson distribution, such that n is large and p is small enough. Okay, only then we can use this equation. We'll consider a few examples and solve the problems based on the previous explanation. The number of defects in a thin copper wire follows Poisson distribution with mean is equal of 2.3 defects per millimeter. Determine the probability of exactly 2 defects per millimeter of wire. What is given in the question? They said it is following the Poisson distribution, and the mean is n given by n into p, which is equal to lambda and given as 2.3. Okay, and the probability of exactly 2 defects they are asking you to find, hence k will be equal to 2. So use this equation, lambda power k e power minus lambda divided by k factorial. Here you will need to substitute lambda as 2.3. See, you just go through the problem. You are not given with the value of n, right? They have given you the mean, and so you need to use this equation for getting the answer. That is lambda power k e minus lambda divided by k factorial. Otherwise, you can go with the previous equation which we have just now shown you, if n value is given to you. Otherwise, if mean is given, that means lambda value will be known to you, then you need to use this equation and you will get the answer 0.26. So now consider the next example problem. A random variable x has a Poisson distribution with mean of 3. Find probability that x random variable x is greater than or equal to 1, less than or equal to 3. Here k ranges from 1 to 3. Hence your equation that you can use here is e power, that is p of x is equal to 1. You need to find what is p of x is equal to 1, p of x is equal to 2, p of x is equal to 3, because they are asking you the probability in the range 1 is to 3. So therefore it is sum of probability x is equal to 1 plus probability of sum at x equal to 2, probability of at x is equal to 3, where the mean is given to you as 3. Therefore lambda which is equal to np equal to 3. K is 1 to 3. We need to find each term x, p of x is equal to 1, that is your k is equal to 1, that is 3 power 1 e power minus 3 divided by 1 factorial, you will get this answer. So similarly p of x is equal to 2, you will get the answer as lambda power k, that is 3 power 2 into e power minus 3 divided by 2 factorial, which is 9 by 2 into e power minus 3. So now similarly find the p of x is equal to, similarly find p of x is equal to 3 using the same formula. You will get answer 9 by 2 e power minus 3. The final answer for probability of x ranging from 1 to 3, you add the answers for p of x is equal to 1, p of x is equal to 2 and p of x is equal to 3. You will get the answer as 0.59744. Thank you. I hope you have understood.